Going once, going twice. We're moving on. So this time I'd like to introduce David Divins from Carpathia Hosting. He's going to give the first presentation on dual stacking hosting services.
Can you use the, how do I advance the slides?
This brings it forward.
Hi. I'm Dave Divins, Principal Engineer at Carpathia Hosting. I'm going to give a brief overview of hosting providers in IPv6 and some issues that we've run into and some things that we've done, and hopefully you'll find it of use. So the hosting providers themselves kind of are a overlooked market. They're really not a traditional ISP and not a traditional enterprise, so a lot of the tool sets and things that we use aren't really designed for the hosting provider, so we've had to do a lot of overcoming in that category. Things are too large or too small or what have you. So there isn't, often a single tool set that we're going to use like an enterprise may or like a large traditional ISP may. The data center and hosting providers use a huge array of equipment. Pretty much if it's made and it supports IP in some sort, it's in a data center somewhere at a hosting provider, and we're doing it. Pretty much everything is there. And another thing is a lot of the web hosters have standalone data centers that don't have a global or an international backbone, so they're standalone pods that might have their own transit, and so they have a lot of multiple discrete networks, as ARIN would put it. So that's an architectural commonality among a lot of hosting providers out there. So to start with IPv6 as a hosting provider, you're going to need to get some connectivity, obviously. The good thing is that that's fairly easy. A lot of ISPs are giving out transit, whether it be native or tunneled. Talk to ISPs, throw a post on Nanog, see who's willing to offer you something. A lot of your current ISPs probably already support dual stack. You just probably have to ask, and maybe don't take no for an answer from the first person that you hear it from. You might have to dig a little deeper to go ahead and get IPv6 support. But chances are the big players do have it available upon request. Again, it might be a tunneled service, but you probably already are right to that service. A lot of your existing equipment that you have lying around probably already supports v6, and it probably has for some time. On most major vendor equipment, v6 is quite stable, and it actually does work as advertised. It's pretty much easy to do. It's kind of fun, it's kind of cool, it's like learning something new, and there's really no reason not to. A lot of contracts that you might be seeing, especially in the government sphere, are going to start mentioning, do you have the ability to do this in v6? So there is a business reason to do it, if nothing more than a checkbox. So there really is a reason to do it, and you do need to put it on your radar. So which IPv6 architecture is right for you is going to be 100% up to you. You know your architecture better than anybody else, but some things that you can do is, obviously you can dual stack, where you just, on a single interface, you run an IPv4 address, you run an IPv6 address, and you could talk native out them. They basically don't know about each other. They're discrete protocols in that sense. And for most equipment, that's good, and depending upon what you want to do, that works very well. You can deploy a completely parallel network for IPv6 only. Depending upon what you're doing, that might be right. Or there's a hybrid. What we did is, I was really concerned when I started playing with IPv6. I didn't want my playing with something as it went production to impact my business-oriented services of IPv4. So, day one, I stood up discrete IPv6 WAN routers and had them go to a discrete IPv6 core, basically made up of excess equipment that I had. And as it became more stable and as I became more confident with it, I started moving services over to a dual stack model. And now we have a mix of both, depending upon where it falls architecturally. So what's really right for you is going to be up to you, but the gear is there. The biggest challenge that we really ran across in doing this was what I refer to as servicing IPv6 versus supporting IPv6. A lot of the gear out there will service IPv6, means it'll process the packets, it'll route the packets, it'll firewall the packets. It'll provide those services to your end customer, but you can't manage the device on IPv6. You can't do SNMP off of it. You can't syslog to a v6 syslog server. You can't get time from a v6 service. That is something that, very gear specific, very code specific, depending upon what you've got, you might run into this, so you need to be cognizant of that as you're deploying things. So what gear you're doing and how your management structure is laid out really is going to kind of be dictated by some of the gear that you're using. Now on the equipment side, routers, Cisco and Juniper, which majority of the market share there, they've been supporting v6 for ages. I found it very stable on pretty much everything I've run from them. You guys probably have something lying in the corner that will run IPv6. We'll probably do it more than enough. Chances are you're not going to be pushing a huge amount of traffic over at day one, so that 2811 you have might be just perfect. That 7206 VXR collecting dust might be a great v6 router. M7s, whatever it be. So you probably have something lying around. Layer 2, if you're doing pure layer 2, they essentially don't care. Again, you might not be able to manage them off of v6, but they will pass the bits for the most part. Load balancers, big market players, F5. It's a license upgrade on the 1500 product line. On the new ones, the 1600 and above to I think the 6900, it's included, it's standard, it works. The Citrix NetScaler, it's standard on their 9X lines, and you can do exactly what they say you can do on it. Firewalls, Cisco's had it for ages on the ASA and PIX line. Juniper's had it for ages, and they keep improving it, and it gets better and better, and as more services come out. But I've been running production v6 on NetScreen-based firewalls for 2 or 3 years now, so you can kind of do the reverse math on the code on that, and I've been extremely satisfied with it. Security products that do support v6, you've got Snort, the Juniper IDP supports it, Gigamon. There's a lot of stuff out there that you might be running that does support it. You might have to dig a little deeper than just your quick manual, but it will be there. For non-compliant devices, you can do, throw one of those Junipers in front and do a 6-to-4 translation if you need to provide those services to customer. If you have an NTP box or a PDU somewhere that you really want trapping to a v6 destination, but it can't do it, there are translation technologies that are available to allow that protocol to work, and so you can integrate those things. So tools, just, a lot of the open source stuff does have v6 built in. Nagios, they're doing v6. Bind, SendMail, there are tools. Obviously, if you guys have custom applications that you've written, you might need to go back to the development team with it if they're IP aware at that level. But again, you can do for internal stuff, you can do translation if you're just trying to, bridge the gap until your developers can, clear something up. So to relate this back to ARIN, when you register for ARIN and you become a member, you can come in as an ISP or an end user. A lot of hosting providers probably are labeled as end users. You probably want to really pay attention to what you're registered as and see if you qualify and become an ISP. Obviously, you're going to know better than anyone else what you qualify for, but being an ISP is probably more appropriate for a true hosting provider, and it will let you take advantage of some of the policies to get v6 addresses easier and to get these things squared away faster. And the IPv6 version of multiple discrete networks, which is the NRPM 611, was just recently ratified and implemented. That was something that we found was deficient in the community, where I had multiple data centers and I can only get address space for one, or if I had to do crazy GRE tunneling because I didn't have a globalized backbone to support these. So we put a policy in front of the community, and the community reacted, and we got it implemented relatively quickly. So people can take advantage of this and have multiple data centers up online together without having to create large tunneled interconnects and some craziness. So that's about it. So, so the challenge is, I would say that true IPv6 only still is relatively difficult because of the servicing versus supporting model. Getting management services on those devices so you can have a router or a firewall or something that is completely IPv4 unaware, I've found to be very difficult, because for the most part, it's how you manage that device. It might be able to get time from v6, but I can't upload code from v6 to it. So you're going to have some sort of v4 address on it. And then if you're doing BGP, you still have the 32-bit field for the router ID. So at some point, there's probably going to be an IPv4 address on a BGP speaker for nothing else than to enable BGP to actually work. But that doesn't necessarily have to be a listener. That's just kind of an internal 32-bit hash, so to speak. And that's really all we've done. But to sum it up, it's been relatively pain-free. It's been relatively easy. The traffic that we see on V6 is not significant, to be honest with you. I think I was looking at, I think it's 6 AMS as peering fabric statistics, and they're pushing about 800 gig on IPv4 and about 1.2 gig on IPv6. So there's a huge discrepancy. However, 1.2 gig is a lot higher than I thought it would be, honestly. So.
All right, thank you very much, David. And thank you, David.